Hello and welcome to a video which is going to sort of complement the previous one on the channel where I showed off loading textures within OpenGL. And I wanted to talk about the texture file opening procedure I created, because rather than using any of the well-known image formats like PNG or JPEG, I decided I would use the only truly based and red-filled image format, Farbfeld, which is really simple. So simple, in fact, that they didn't even need an HTML table to describe it. So I'm going to write a parser for this format right here, and then show off a slightly better version I wrote earlier. So let's see, we'll call it farbfeld.c, why not? And I think we're probably going to need the standard library, seems like a fairly good bet. And what else are we going to need? We're going to be wanting to use a file, so we'll get standard IO as well. So first, what is the function going to return? That's the critical thing. It's going to return a structure, because what we want to do is produce an image structure which is going to contain the information from this that we want. So what information do we actually want from this? Given that there's only one resolution and there's only one bit depth it can have, all we'll need really is, oh, that reminds me, we're going to need standard int as well, because all we really need is uint32 width and uint32 height. And then a very particular thing, let's see if I can get this right, I think it's uint16t, and then we need a pointer to an array of 4 items. I think that's right. Here, I'm just going to quickly cross-reference with my existing example. That's no good. Oh, so here we are. Yep, that's right. This will create an array of an array of 4 uint16s in a 2D array. So each item will be one of these holding the R, G, B, and A values. So that's what we want to produce. So now, for the sake of simplicity, I'm just going to return the image. You can get all fancy, but we're just going to do that. So I'm going to use really abusively short function and variable names for time. So first, what do we want to do? Well, we look at the image and see it's got this Farbfeld magic value. Now, what is that? So I have a nice file here we're going to examine. It's a Farbfeld file, in fact. So first we have these 8 bytes here, which are the magic value. So we want to skip past that to be able to actually get the image data. Now we could, in theory, check what these 8 bytes were to make sure that this was in fact a Farbfeld file, but we're going to assume whoever's calling the function knows what they're doing. So to skip past, we want to take the file and then skip the 8 bytes from, I think, may as well go from the current thing in case the call is doing something fancy. Now, if we want to be really clever, what we can do is actually explicitly state what we're doing. So this will skip the 8-byte characters of this string, and then -1 to remove the null byte. So that'll then skip us to the next one after that, which is going to be the width. So how do we do that? We're obviously going to want fread next. So we then fread. First we want an image, of course. So we want this of img dot width, and its size of uint32t, and we want to read 1, and I think that's, and then we just give it the file, and then we do the same thing but with the height, and then what we can actually do is allocate memory for the data, because at this point we know the width and the height of the image, and we know the resolution, so we know exactly how much memory we're going to need for the data if it's all there. And again, this doesn't have error checking for the sake of time, but we can say we want image.width times image.height times, I think, 4, because there are 4 of these 16-bit integers. So 4 times the size of 16-bit integers, and then that'll give us the stuff we want. And I've not done that. Okay, so now that's going to put that in there, and then we can just read the rest of that data all at once into the data variable right there. So size is going to be, again, 4 times size of u int 16t, and the number of these pixels, actually is what they are, is going to be image.width times image.height. And then we just read that from the file, and then the data's there, so we can just return the image. And as it turns out, this isn't going to work, because you see this B, that is big endian. That means that the bytes are backwards. So if we have a look at this image, you may be curious to know what it is. It's just a nice pic drawing which explains what we need to do. So in the file, we're going to have these bytes A, B, C, and D like this, but then we need to swap them around in that number, and that's what this function here is going to do. So we're just going to import that. There's a POSIX function which does the same thing, but I wanted it to be portable, so I just implemented it myself. Basically, if you know how you go about this, then you'll understand how the function works. So, but if you don't, you can just ignore it, because I don't know what you're doing. But then what we need to do is essentially run that function on the width and the height, just so that they're going to be the right way round, because normally when we're doing stuff we want little endian, and what this means is that with big endian the most significant byte is at the front, and with little endian it's the other way around. I think it's something like that. Or maybe big at end. That would be sufficiently low brow enough for a programmer to understand, so maybe that's what it is. But now we've done that, I think that is equivalent to the one I made earlier, which is the same thing, but it's got some error checking and allocates on the heap, so it's a bit more robust. Yeah, that's just going to go in and do pretty much the same thing. Yeah, and then we've got some pretty straightforward destruction functions to clean up, and then a loading function which actually creates that file pointer for us in case we wanted it. And as you saw in the previous video, I'd hope this is the texture that I was loading using OpenGL, and part of the reason I did this myself was because I wanted to use Zig, which doesn't really have the support for these things, and really the problem was STB image, which is what this tutorial recommends, is entirely implemented in a header file, which just makes Zig explode. So I had to do this and then call my function here and then do all the good stuff, and because because each of the RGBA values are 16-bit, we've got to use an unsigned short here, and then that will do all of the good things to then give us our wonderful program.